Welcome back to my lecture on probability and statistics, and in this section we're going to be talking about multiple events. So far we've been talking about what is a probability function, and for that we created a sample space, and it was a bag of marbles with 2 red, 3 green, and 1 yellow marble. Okay, so this is our first sample space, and for this we had our we had our probability function, I'll call it over our first sample space, and it took us from a special subset collection of our sample space onto a probability, which is a number between 0 and 1 inclusively. All right, but let's say we have another sample space, and we'll do this in a different color, and we'll call it S2. And this is just going to be a coin flip, and it can be tails or heads. Okay, so then we have another probability function over S2, and that will be a map from, oops, we should probably call this 1, and we should call this 2, and this will take us, again, to a number between 0 and 1 inclusive. So the question we might ask is, let's do this here, what is the probability of red or tails? So this is a question, right? So we know from our previous section, we know the probability of red is 2 out of 6 or 1 out of 3. So let's say I have, well, probability of red is equal to 1 out of 3, and probability of tails is a half, right? I have tails is 1 out of 2, and red is 2 out of 6 or 1 out of 3. So well, if it's this one or that one, can't I just add them together? Is this equal to 1/3 plus 1/2? And right here, we're going to put a question mark. Is this true? Well, the answer is no, because let's look at it this way. What would be the probability? Let's try another one. Let's try probability of green or tails. And this will make it a little bit more clearly. If we follow the same logic, we would get 1/2 plus 1/2, which equals 1. And this would imply that we could only get green or tails. And we know that's not true because this green and tails is not equal to heads, tails, the combined sample space, red, red, green, 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 yellow. These two sets are not equivalent, and this is the total sample space. So we can't get green or tails equal to probability 1, so we know that this is not true, okay? So since that's not true, we're missing something here. We're missing something here, and we don't know what that is yet. So one thing is that since we have two sample spaces, we have a marble and we have a coin, we're drawing a marble and flipping a coin. So both of these two things, so that's because, so we'll say because the probability of green and tails is not equal to 0. So what we're going to do here is we're going to modify our question. We're going to say, okay, so I know that the probability of green is equal to 1/2. The probability of tails is equal to 1/2. But what is the probability of green and tails? What is this equal to, right? Well, before we get into conditional probabilities, it's convenient that our coin flip and our bag of marbles here's our bag of marbles and our coin flip, they're independent. Picking a marble does not impact flipping a coin. So because we know that they're independent, I know that what that means, and I'll just write this right here as an assumption. Well, this knowing, I'll put knowing, and this will help us later. The probability of green given tails is equal to the probability of green, and the probability of tails given green is equal to the probability of tails, because I know getting a tails doesn't change what marble I pick, and I know that picking a green marble doesn't change my coin flip. Then this is equal to the probability of green times the probability of tails. And I know that this is equal to 1/2 times 1/2, which is equal to 1/4. So really what I need to do is I need to modify my original part here. This needs to be modified considering that. So now the new probability of green or tails is equal to the probability of green plus the probability of tails minus the probability of green and tails. And this is now going to be equal to 1 minus, and right here we have 1/4, so this is 3/4. And similarly, up here, we have to subtract, remove the question marks, we have to subtract red and tails, and it's the same logic, minus, and I'll just put it in parentheses, 1/3 times 1/2. And there we go. That is how we handle an or statement in two sample spaces. So now we have a new combined sample space where two things can happen simultaneously.